Welcome. This video is about Pascal's triangle and how it is connected to the binomial coefficient or the binomial expansion. So first we start with Pascal's triangle. How is it constructed? We start here with a 1 on the side and also here a 1 and a 1, and 1 plus 1 equals 2, and then here 1 plus 2 equals 3. So on the boundary, you see there is always a 1. 1, here we have 4, 6, 3 plus 1 is 4, 1. And then even more, 1, 5, 10, 10, 5, 1. And one more row, so I don't write the 1 here outside. We have here 6, 15, 20, 15, 6, and 1, and so on. So this is Pascal's triangle. And the first observation is, where does this actually appear? And we will actually see that when you have a binom, because we have 2, and you power it by n, you can read off the coefficients from Pascal's triangle. And I would say we start here with the second row, which actually is a plus b squared. So it's actually the second row. I write it a bit below. And here we start counting with 0, 0, 1, 2. So we are here, yeah? So a plus b squared, and you know it is a squared plus 2ab plus b squared. And where are the coefficients? Here, 1, 2, 1. So next formula, probably you also know it and you can memorize it. So it's a cubed plus 3a squared b plus 3ab squared plus b cubed. What about the coefficients? Okay, it's 1, 3, 3, 1. Interesting, yeah? So let's go on with a plus b to the power of 4. So, and you also see some structure here in a and b, because you start with the highest power and you decrease to 2. Here is a hidden 1, and to a power 0, you can say. So if you want, you can also include here a power 0. And here you include the b power 0, you increase to b power 1, b power 2, b power 3. Interesting. So we actually can compute based on this structure a plus b to the power of 4. So coefficients we can read off. 1. Decrease the a, use the coefficient of Pascal's triangle, which is 4. Decrease the a by 1. Increase the b from 0 to 1. And now go on. Pascal's triangle says it's 6. Decrease the a power, increase the b power. Use the 4 from the Pascal's triangle. Decrease a power, increase the b power. Plus the last one, it is 1 times b to the power of 4. If you decrease the a power, which is here the 1, it's a power 0, and it is not here anymore. A power 0 is 1. Yes, and for training, you can also write down what is a plus b to the power of 5. And I just give you the answer and you can compare yourself. Plus 10. Structures are really nice. And no one has to memorize such a complicated formula. Great. So we have this connection now. Then we look at the definition of the binomial coefficient. I quickly recall this is n factorial divided by n minus k factorial times k factorial. And what are properties of this? First of all, one can prove that n choose k is n over n minus k. Then one can prove that n choose 0 is 1. N over n is also 1. N over 1 is n. So this directly follows from this definition here. And I also need probably the last one. N over n minus 1 is n. So you can prove it yourself just plugging in n over n here, and you see n minus n is 0, and it cancels out and will become 1. Okay. And now, can we see this in Pascal's triangle? What is the first entry 1 here? It is actually 1 by 0, and here 1 over 1. So you can say 1 is the first, when starting counting at 0, it's the first row, first 0 column, first column. This is clear from these properties. So whatever n you use and you have 0 below, it's always 1. So that's why we always have here 1s. So the same to choose 0. And if it is full, like here, n, it's also always 1. So you can actually write here 2, 2, 3, 3, 4, 4. And same on the other side. 3, 0, 4, 0. Okay, what else do we have? Next property, if you have n, choose 1, you directly get n. You can just copy the n. So what does it mean here? We have here, this is 2, 1. You just copy the 2. And here it is 3, 1. Great, also works. 4, 1. And similarly, on the other side, you have n, choose n minus 1. So in this case, it is 3, 2, 4, 3. So, and there is even one more property. This is a symmetry property. N choose k is n choose n minus k. So what do you see? They are always symmetric. 4, 4, 5, 5. Also here the 10, 10. Yeah. Or 15, 15. Always symmetric. There is even one more property, how actually to explain the 6 here. And you also will prove in the lecture or for homework this one. This property, it looks a bit difficult in general, but as I always say, plug in numbers. So for example, here 3, 1 plus 3, 2. What is it? According to this rule, you have to increase the 3 to 4, so 3 plus 1. And you have to use k plus 1, which is actually here 2. So we have 4, choose 2. And you can see it here in Pascal's triangle. And this is what we did. We constructed it like this, that we added 3 plus 3, these two. 3 plus 3 was 6. Fine. So the only remaining thing is how to develop the binomial expansion. I hope I have enough space here. What is a plus b to the power of n in general? And if you check out these formulas here, it's a summation, first of all, from index k0 up to n. And these red coefficients are just the binomial coefficients. Yeah, use the binomial coefficients. So the red coefficients are n choose k times a to the power of k and b to the power of n minus k. Or actually how we used it, we did not use it like that actually. This is the same. N choose k, a to the power n minus k, and b to the power of k. So if this is too fast for you, just for example, plug in 2. So if you plug in 2, you start with 2 choose 0, which is 1, and a to the power of 2, a to the power of 2, b to the power of 0. So it's this one. The next index, if k is equal 0, the next index is k is equal 1. So you have here 2 choose 1, which is 2. A to the power of 2 minus 1, so it's a, b to the power of 1. And the next one is if k is equal 2, analogously. So this is the famous binomial expansion. One last property on this is the following. I will directly write it up here. So if you plug in for a and b is equal 1, then you have here 1 plus 1 to the power of n. 1 plus 1 is 2. And you also have a summation formula. But if as a and b are equal 1, 1 power something is always 1, you just have the summation of the binomial coefficients from k0 up to n. So this is a special case. And what does this mean? If we sum up the binomial coefficients for k, so this means per row, per line, you get 2 to the power of n. And now we try it out. 1 plus 1 is equal 2, which is the 2 to the power of 1. 1 plus 2 plus 1 is 4, which is 2 to the power of 2, 2 squared. 1 plus 3 plus 3 plus 1 is 8, 2 cubed. And one more, 5, or let's compute like this, 10, 11, 12, and plus 4 is 16. It is 2 to the power of 4. And if you still not believe, compute the next one. So 20, 30, it's 32. The sum is 32, which is 2 to the power of 5. This is kind of a nice property. This is all about Pascal's triangle. You have all the properties. You do not have to memorize these in general because you can read it directly off Pascal's triangle here. Thanks so much for your attention and see you next time.